Hi guys, so in this tutorial we'll be discussing about how to insert a new node in the end of simply linked list. So let's get started with graphical representation discussion. Here we have head which will be pointing to the first node of simply linked list, and if there are no any nodes available, in that case head will be pointing to null like this. So in this use case we have to add a new node with any data, and you can see this is the code which will be creating a new node with data 50, and the reference of newly created node is pointing to null by default. So our job is head should start pointing to newly created node. So that is taking care of this line of code. Head is equal to new node. When we execute this line of code, so head will start pointing to newly created node. Let's execute this. Now you can see here head is pointing to newly created node, and the previous reference of head which was pointing to null is no longer available. So this is the first use case. Now the second use case is when there are nodes available and head is pointing to first node of simply linked list. Now our current pointer is pointing to wherever head is pointing. Now we have to add a new node in the end of simply linked list, but our control is pointing to the first node of simply linked list. Now we have to traverse each of the node till we will not reach to last node of simply linked list. So to traverse each of the node, we'll be using here pointer approach. So here we have one pointer which will be keeping a record of every node of simply linked list until it will not reach to the last node of simply linked list. So before moving one step forward, it will be checking whether current.next is pointing to null or not. So if it is not pointing to null, so it will move one step forward, and the moving one step forward is taking care of this line of code, the statement inside if block, current is equal to current.getNext. So let's check this condition first, whether current.next is pointing to null or not. So current node is this node which has data 10, and the next of this node is 20. So let's now this condition is true, and this expression or this statement of if block will execute, and when we run this line, it will move our pointer one step forward, you can see. And now again in second iteration it will check whether current.next is pointing to null or not. So it is not pointing to null because next to node which has data 20, and that reference is pointing to next node which is data 30. Now this condition is again true, and this this statement which will be taking care of moving our current pointer one step forward, so will execute. So let's move this. Now you can see again likewise it will be keep checking the current.next status is pointing to null or not. If it is not null, it will be moving current pointer one step forward here. Now again it will check whether current.next is pointing to null or not. Now it is pointing to null, and this condition will be false. Now if this condition will false, it will not come inside this block moving current pointer one step forward. This will not execute, and now our current pointer is pointing to last node of simply linked list. Now next to that we have to add new node. So before adding a new node we have to create a new node. Okay, now let's create a new node. So you can see here this is the line of code which will be creating a new node with data 50, and the reference of this newly created node is pointing to null by default. Now our job is, so this current pointer should start pointing to newly created node, right? So that part we can achieve using current.setNext is new node. So current setNext means we are setting the next value of current pointer to newly created node. See, new node is this, whatever newly node we have created. This is the reference of newly created node. So current dot set next. We are setting the next of current node is new node. So current node next should point to here. So let's execute this line of code, and you can see current reference will start pointing to newly created node. See this. So this is start pointing to newly created node, and the previous reference of current node which was pointing to null is no longer available. So you can see here we have added new node in the end of syncly linked list, and it is framing a chain of syncly linked list. So this is the graphical representation discussion of inserting node at the end of syncly linked list. Now let's get started with backend code. So for that I have created one class here, insert node at end, which will be taking care of writing logic of inserting node at end of the syncly linked list. So let's get started with program. Private void method name will be insert add end, which will be taking care of data of integer type as input parameter. Now the first use case will be checking if head is null. If head is null, then add newly node as first node of syncly linked list, and head will start pointing to newly created node. Now let's handle this use case, but there is no any head for now. Let's create head first. Node head. Now let's check whether head is null or not. If head is null, then we have to add. Okay, we haven't create new node, so let's create new node first. Node is equal to new node with data which we are getting from parameter of insert at end method. Now we'll be assigning node to head. So this use case we have handled here, but if there are nodes available, in that case we have to handle that use case as well. So in that case we will be using one current pointer which will be keeping the exact copy of head. Now we'll be using for loop here, which will be you can use for or you can use while loop. It's up to you which one you want to use. I'm using while loop here. So I'll be checking whether this current dot next is pointing to null or not. Current dot get next. If it is not null, we will be keep moving our pointer one step forward. So when this condition will not execute, means this condition will false, it will come outside of this loop, and that time our current pointer will pointing to the last node of syncly linked list. So now when we are at last node of syncly linked list, now we have to ask to this node to connect with new node. Now this is done. Now we have handled the second use case as well, when there are nodes available. If nodes are, we will then add newly created node at last of in the end of simply linked list. Now we have handled this use case as well. Now okay, there is some, I think, oh, I have done spelling mistake here, not an issue. Now let's write main method to verify whether our logic is working fine or not. So let's create the current class object so that we'll be able to access the member of this class. Now list dot insert at end. Let's call this method and pass data 10 as initial node. Now we have print linked list method, which will be taking care of printing all the elements of simply linked list. Now we'll be passing here head of linked list. Linked list. All right. Now let's run this program and verify whether we are getting a node like this 10, and the node 10 reference will be pointing to null. Let's run this now. Now it's running fine, and let's add one more node at last 20 and 30. Now output should be 20 and 30, and 30 reference should pointing to null. You can see here 10, 20 and 30. So 30 reference is pointing to null. So you can add one more value here. Let's pass 40 and then 50. Let's call this printing all the elements of simply linked list method again. Okay, now let's verify. So you can see here till this we have inserted this. Now after 30 we have inserted 40, and 30 is pointing to 40. Now after 40 we have inserted node which has data 50, and 40 data node which is pointing to 50 now, and there is no node next to 50, and 50 is the reference of 50 node is pointing to null. So this is working fine, and we have done with this video, guys. Thank you so much for watching this video, and stay tuned for another interesting videos. Thank you.